Welcome to Statistics, where we bring complexity to clarity. I am excited to have you join me for our 15th unit Z test. Let's study Z test. It is defined as the ratio of the difference between the estimated population mean and hypothetical mean to the standard error of mean based on population standard deviation or its estimate from large sample. It is a large sample test and can be utilized for testing the hypothesis if the following conditions are satisfied. That is, if the data follows normal distribution. The sample size is large, that is n greater than equal to 30. Or the standard deviation of population should be known if sample size is not large. Here you may recall that in case of t-test we saw that sample size was less than 30 and standard deviation was not known. Now let's discuss one sample Z test. Here the objective is to test whether the given large random sample has come from the given population with mean mu and variance sigma square or its estimate S square. Let's see the procedure. If ungrouped data has x1, x2, xn as the given sample and greater than equal to 30, or in grouped data class values x1, x2 up till xk with corresponding frequencies f1, f2, fk is the given sample, then we have to follow the given procedure. Let's see it in stepwise manner. The first step is to set the null hypothesis at 0 mu is equal to mu 0 or mu minus mu 0 is equal to 0, and alternative hypothesis as mu not equal to mu 0 in case of two-tailed test, or mu less than mu 0 or mu greater than mu 0 in case of one-tailed test, where mu is the population mean from which the random sample has been drawn and mu 0 is the mean of the hypothetical population. Step 2 is to fix the level of significance. Usually 5 and 1% levels of significance are fixed. The critical values of Z will be as shown in the given table. If the level of significance is 5% and it is a two-tailed test, the value of Z is 1.96 and in case of one-tailed 1.65. And if the level of significance is 1%, then the value of Z is 2.58 and 2.33 for two-tailed and one-tailed respectively. The third step is computation, that is, we have to compute the given estimates, that is mean, variance and standard error of mean for ungrouped data or grouped data using the given formula. The fourth step is to calculate the normal deviate using the given formula, that is Z is equal to modulus x bar minus mu 0 divided by Sx bar, and here we have to put the values of the variables calculated in the previous step. The fifth step is conclusion. If the calculated Z is less than 1.96, the observed difference is non-significant at 5% level of significance and H0 is accepted. Acceptance of H0 means the given sample has come from the population having mean mu 0. Whereas if calculated Z is greater than equal to 1.96, the difference is significant at 5% level of significance, and if the calculated Z is greater than equal to 2.58, the difference is highly significant at 1% level of significance. And H0 is rejected in both cases. Rejection of hypothesis indicates that the given sample does not come from the population having mean mu 0. Now let's discuss two-sample Z test. Here, the objective is to test whether the two randomly selected samples have come from the same population having mean mu and standard deviation sigma or its estimate S. Generally, there is little interest in comparing sample mean with population mean. A more frequent problem usually met with in agriculture is involved in comparison of two samples, that is means of two samples. For example, we may require comparing variety A with variety B of a crop, comparison of two manure for their effect on yield, comparison of two ratios for milk yield, comparison of yield of the same varieties on two different farms, etc. Need to be tested for their difference in means for location specificity. Now here the ungrouped data observations in sample 1 are denoted by x1, x2 up till xn1, and in sample 2 they are denoted by y1, y2 up till yn2. And in case of grouped data, the class values for sample 1 are denoted by x1, x2 up till xk1, and for sample 2 y1, y2 up till yk2, and their corresponding frequencies are denoted by f1, f2 up till fk1 equal to n1 for sample 1 and f1, f2 up till fk2 equal to n2 for sample 2. Here samples 1 and 2 are drawn from normal populations. Let's see the procedure in stepwise manner. The first step is set the null hypothesis at 0 mu1 equal to mu2 equal to mu. Here both the samples have come from the same population having mean mu and standard deviation sigma or its estimate s. And the alternative hypothesis will be HA mu1 not equal to mu2 for two-tailed, or mu1 greater than mu2 or mu1 less than mu2 for one-tailed, where mu1 is the population mean from which sample 1 is drawn and mu2 is the population mean from which second sample is drawn. The second step is to fix the level of significance, which is usually 5% or 1%. Step 3 is to calculate the following estimates. That is, we have to calculate the estimates sample mean and sample variance in the similar way as that in one sample Z test. But here we have to calculate it for both the variables, namely x and y, using the formulae shown here for ungrouped and grouped data respectively. And then we have to calculate the pooled sample variance, that is SP square, which is equal to summation I is equal to 1 up to n1 xi minus x bar square plus summation I is equal to 1 up to n2 yi minus y bar square whole divided by n1 plus n2 minus 2 for ungrouped data. And SP square is equal to summation I is equal to 1 up to k1 fi into xi minus x bar square plus summation I is equal to 1 up to k2 fi into yi minus y bar square whole divided by n1 plus n2 minus 2 for grouped data. Then we have to calculate standard error of mean of differences, that is s x bar minus y bar, which is equal to square root of SP square into 1 upon n1 plus 1 upon n2. The next step, that is step 4, is to calculate normal deviate, that is z. Z is equal to modulus of x bar minus mu1 minus y bar minus mu2 divided by s x bar minus y bar. Thus, we can get the value of z by substituting the values of these variables calculated in the above steps. And the fifth step is conclusion. If calculated z is less than 1.96, the observed difference is non-significant at 5% level of significance, and H0 is accepted. Acceptance of H0 means both the samples have come from the same population. Whereas if calculated z is greater than 1.96, the observed difference is significant at 5% level of significance, and if it is greater than or equal to 2.58, the observed difference is highly significant at 1% level of significance. And H0 is rejected in both cases. Rejection of H0 means both the samples are drawn from two different populations. Thank you for joining me on this journey through our 15th unit Z test. If you found this unit helpful, don't forget to like, share and subscribe to Statistics for more insights and clarity on statistics. Your support helps us continue creating content that makes complex topics simple and accessible. Follow us on Instagram and LinkedIn.